Recording in progress.
Michael, all yours.
Right. Now, first, a word of warning. I can't see the clock from here. This is one of these well-designed lecture theatres. When I did my run-through, this took 4.5 hours. So when it gets to 3 hours, perhaps Roger can shut me down. Okay, I'm going to start with a rhetorical question. I want to know what's the connection between John Snow, the 32 cesspits in Derby Court, and the London cholera outbreak of the 1840s, between Mrs. Slocum's feline companion, between Barrovian metamorphics, and between the station master at Kippax station, who directed a long goods train into a short goods siding. Now, if I haven't answered this question by the end of the talk, please fire away. Right, let's see if, okay, I think you all know quite a bit about BGS. We are part of NERC, the Natural Environment Research Council. And as far as the NERC funded grants, we look after any geoscience data that comes out of it. So if anyone's got a NERC grant and is doing geological work that involves physical specimens, their data management plans come to me for approval. And we have to make sure we're happy with archiving arrangements or whatever it is. NERC, of course, is now part of UKRI, the overarching body responsible for research and innovation in the UK. BGS's budget, it's about a bit over 50 million in terms of operating costs and more for, obviously, capital investments. But that is partly paid by your taxes through the government and partly earned by consultancy, selling maps, and all the other work that we do. And we operate across the world. So at the moment, I'm heavily involved in helping the Nigerians set up a course store similar to the one that we've got. And as well as, obviously, ourselves through UKRI, we're a part of, effectively, we're funded through BAYS, but we also work with a whole series of government departments. Anyway, tonight, I'm going to start by talking a little bit about the scope of the collections. I'm going to explain why we spend the money holding them. And then the meat of it tonight is the history of the collections. And if there's time at the end, a little bit about how we're making them available and the future databases, aggregation, and so forth. But the intention is actually to not a high-powered academic talk, more a sort of chat amongst friends, some interesting stories, and to put the collections that we hold into perspective. So in terms of scope, well, let me just introduce you. Probably one of the most exciting things that's happened within collections since you could argue, since we introduced permanent identifiers, registration numbers 150 years ago, is a project called Dissco. It stands for Distributed Science Collections. And sadly, we are behind Europe, and Europe is behind the States. In the States, they've put about $160 million into digitizing their natural science collections because they realize that a lot of the answers to some of the big challenges, climate change, biodiversity, sustainable resources, all that may actually be already with us in terms of collections. So if you're doing, say, modeling climate change, and you want to extend your model back to see if it fits 100, 200 years ago, you may well need to get some historical samples, shell samples, get isotopes or whatever it is. And you need to know which collections where have got those samples. So the States is now well advanced. Europe started 3 or 4 years ago, and Britain is just starting. It's called Dissco. And if you look on the website for the abstract for this talk, you'll find all the links. But this is the dashboard they've produced. And what it shows is that so far they've got 83 collections. Now there's a lot missing. Sadly, of course, Leicester New Walk Museum is missing because sadly Mark is no longer there. Leicester University, I think, is missing, could be there. This is to try and pull together all the natural science collections in the UK. And if anybody is interested, anybody knows of collections that aren't on the list, please contact Dissco UK. The contacts are all reached from the URLs, the references on the abstract. So in the UK, in the 83 organizations that have signed up to the Dissco project so far, 137 million specimens. BGS, we reckon our object count is 13.02 million specimens. Now, it's all a question of how do you count a 1,000-meter core? Is that one specimen? Seems a bit unfair if you count a slide with, let's say, 1,000 microfossils as, well, do you count it as one slide or do you count it as 1,000 microfossils? There's all these problems about how you count it, but I think we've got a good argument that the BGS collections of basically UK geoscience material, over 13 million specimens. The nearest contender, of course, is the Natural History Museum, 72 million specimens in total. But if you delve a bit deeper, you can select for just geological specimens, and they've got about 10 million. So I would argue actually the BGS collections are the largest geoscience collections in the UK. So what have we got? Sorry, I'm doing two jobs at the moment. In terms of the scope, we have boreholes, 600 kilometers plus of drill core. Some of the earlier boreholes broken up into individual specimens, more than 1 million of those from 10,000 boreholes. We have something like 300,000 petrological rock thin sections, 1 million petrological and mineral specimens, 5 million plus fossils, and we've got over 250,000 in our main reference collection, type, figured, cited, and good reference collections. Records, 17.5 linear kilometers of shelving, and digital, well, it's now actually into the petabytes. So it is massive holdings. Running you through some of the larger collections, onshore boreholes, good coverage, certainly in England, mostly in the areas of economic interest. There's a lot of coal, a lot of, well, there's 2,000 oil wells, there's water boreholes, there's quite a lot drilled by the survey just to explore the geology. And of course, there are mineral boreholes. Whoops, I don't know what's happened there. Marine, we have really two sorts of specimens here. We're talking about the hydrocarbon wells. So this is all the North Sea oil wells, Morecambe Bay gas fields and so forth. Anyone drilling for oil or gas has to send a set of core and cutting samples to BGS, and they're available then to be studied by other workers. As well as those, we have a lot of other marine samples, and these are seabed samples, relatively shallow drill cores and so forth. But again, pretty comprehensive coverage of the UK continental shelf. A lot of the borehole samples, as I said, we hold the more recent ones as sticks of core. The older ones were broken up looking for fossils, and their index, that's the million hand specimens. And of course, when you're drilling, you're not always taking solid rock out. Sometimes you use a bit that grinds it all into fragments. They're recovered, washed, dried. They're known as cuttings, and we hold those in either in envelopes, or the older ones are in glass tubes. And we store this, I think many of you may have seen it, inside now 3 large storage halls. This is the latest, and we've gone to movable racking to get everything in. So at the press of a button, about 1,000-ton rack will just slowly move across. It's all designed so that it actually accelerates very slowly, moves gently, and then decelerates. And it stops just before it gets to the next one. There's no bouncing and vibrating. We have to keep everything safe and intact. And of course, the stuff that's higher up, well, all the stuff we use what we call a man-up narrow aisle forklift or high racker, and the operator sits in the cab, goes up to the level of the pallet, puts the forks in, picks the pallet up and brings it down. We then take it through to the examination labs where our staff or visitors look at it. And here, this is Imperial College. They regularly bring 60 students sometimes to work on some, this is onshore hydrocarbon material. They actually look at cores and then go up to Derbyshire to see the similar rocks in situ. Other collections, petrology, paleo, geochemistry. Geochemistry is a very good coverage. It started particularly in Scotland and Wales with pan sediment samples, stream sediment samples, looking for heavy minerals, looking for basically metal resources, but it's now extended to cover the whole of the country with soil samples, and it's used particularly around London and the southeast as effectively a baseline in pollution studies. Paleo, as you can see, not much in the metamorphic parts of Scotland, but plenty in England and Wales. And petrology, of course, there's far more varied rocks, shall we say, up in Scotland. Paleo, well, this is Edward Forbes, who was the first curator. And this is the way we store that 250,000 reference samples. So these are 220 original mahogany cabinets, drawers, tight-fitting lids. That has all the 250,000 macrofossil type, figured, cited, and other good examples. And the whole idea was a field geologist could bring some samples they collected in, pull some drawers, because everything is arranged basically stratigraphically, and then by fossil group. And it was fairly easy to get to the relevant drawers, to get some IDs, then to go to the literature to get the dates. This is what they actually look like, some trilobites, graptolites. As well as the stuff in the drawers, of course, we also have, we were heavily involved in the Charnwood Ediacaran biota project. And this followed on from Section C, the 2007, I think, meeting on Charnia at 50. We had Guy Narbonne over and asked him on a field trip, a small field trip on the Sunday afterwards, how come you've got thousands of your fossils on your bedding planes and we have in this quarry 3? And he said, well, it's got 180 years of algae, moss and that, clean it up and have a look. So that's exactly what we did. And with money from Natural England, we then molded it. And as soon as you mold it, you put a wash on it to highlight a little bit of the relief and then light it correctly. And we found instead of the 3 that we could see in the field, we actually had over 1,000 fossils. And that, of course, is where the stuff that Frankie Dunn, who talked to you recently, comes from, along with work along with fossils that underpins PhDs by Charlotte Kensington, Emily Mitchell, and others. So this has been a really important, productive project. And the material, the casts and the original silicon rubber molds, they're all archived at BGS and available for further studies. We've also got mineral collections. Now, when we moved out of London, we left most of it behind with the Natural History Museum. But since then, we bought a collection from a private individual, Patricia Thorman, and we also have taken, now taking over the collections of the Royal Geological Society of Cornwall. So here are some examples of minerals in the Royal Geological Society of Cornwall collection. Then we have some interesting, rather unique collections. So part of BGS's work during the 40s, 50s, and 60s was working very closely with the government on atomic energy. And we were heavily involved in work in the Commonwealth on sources of uranium. and other radioactive minerals. And we now have a major collection of radioactive minerals, and these have recently been completely audited, photographed, and are now in a purpose-built store, because we had problems. The level of radioactivity produced high levels of radon gas, and it was a good opportunity to build a new store to move things through. It's got special extraction, the airflow's monitored, the floors, walls are all washable. But actually, the way we could afford this, we actually gone in with a natural history museum. So this particular store was half paid for by BGS, half by the Natural History Museum, who had a very similar problem. They had a lot of radioactive minerals very close to the public, so they couldn't access them. So these are now all together in one site, and it's now a source for a lot of research projects on radioactive minerals. We also have asbestos, and this was one of these occasions where, on a routine check by the asbestos consultants, they managed to find a flake of white asbestos on one of our storage trays. Probably came from somebody's clothing. They probably had it on an asbestos pad, or maybe somebody had been working on car brakes 50 years ago, but somehow a particle of asbestos got on one of the trays. And with health and safety as it is today, that was a major concern. So it actually worked out very well for us, because we got central funding to bring specialists in to go through the entire asbestos collection, decontaminate it, double bag everything, and do a complete photographic audit. So we now have, for all our asbestos minerals, a full photographic record, full database. So they're now available because they're all double bagged. You can get at them again, and they are now available. We have the facilities for opening the double bags and for working on it. As well as the geomaterials, the actual physical specimens, rock specimens and so forth, we obviously have, as I mentioned, a lot of records. Many of them are very well organized. It's easy enough if they fit into bankers' boxes. For maps and for long seismic rolls, it's more difficult, but we have techniques with, obviously with rolls, index rolls, and we have a fairly compact hanging map storage system. So we have everything well organized and under control. And I should say, what I've shown you so far is all in Keyworth, and that's the England and Wales collection with some Scottish, but most of the Scottish rocks and fossils are held up in our Edinburgh office. So if you want to see those, then that work is normally best done up at the Lisle Centre. And of course, on all the collections, we have the original paper registers, probably in excess of 2,500 volumes of registers. And we are in the middle of, we have scanned many of these, and we're just starting a crowdsourcing project. We have a website that's going to go live in a month or two. We have some GA, Geologists Association volunteers, who are keen to help us, basically transcribing from here onto an online spreadsheet. We, and I know the Natural History Museum and a number of others, have looked at optical character recognition for script, but the thing is, there's so many different handwritings, so many different annotations, and so many of these are in variable columns that OCR is not clever enough yet. It really has to be done by a human being. And the other thing is, a lot of them actually almost indecipherable anyway, and use variable abbreviations. So it is, I'm afraid, it's a job for keen, enthusiastic volunteers. Of course, these collections then underpin a whole series of technical reports. And the interesting thing is that many of these are in a fairly standard format. So you've normally got a locality, probably with a grid reference. You've got a list of fossils, and you've got an age and some comments. So it's the ideal thing. In fact, we're now doing AI work actually investigating, scanning some of these reports to see if we can get effectively more out using AI techniques. Why whole collections? Well, I'm sure to most of the people here, it's obvious. Science depends on being reproducible. So if you're publishing something that's based on a borehole or a sample, you have to archive at least something, because if somebody, and I've told one of our previous directors this on a few occasions when he said, oh, I didn't archive any of my PhD. But if somebody then said, we're unable to confirm the results of a certain person because there's no archive specimens available, so we're ignoring the research. It's caveat, you've got to be careful. It's important that you archive material to prove the quality of the work you've done. And of course, in some cases, we actually have some stuff that's some borehole material that relates to geotechnical work related to construction projects that have run into problems. So there is actually litigation going on. So it's important to keep that material when there's a potential for litigation. But the main reason is, of course, to drill a borehole is extremely expensive. And if you are, say, a minerals company and you think that there might be a prospect you can work up, you need to get some data to put a business case together to go and get more funding. And if you can access some boreholes and data relatively cheaply, that can make the project a goer. Whereas if you had to go out and drill from scratch, it would probably be too risky, too expensive to start. And of course, things like type fossils and that we have, they are by definition unique. So you have to hold them. So let's just give some examples of that. This is the Museum of Practical Geology, and there's various references in the literature to fossils that were in there. They were called variably the Museum of the Survey, Museum of the Geological Survey, Museum of Practical Geology. That's all the same place. But in actual fact, not all that material is with us now, because the one in yellow, because it's presented by the Imperial School of Mines from Petersburg, it's a Russian specimen. And actually in 1888, most of our overseas material was given to the Natural History Museum when they moved to their new premises. So the Geological Survey Museum was almost full at that point. The sense was that it concentrated on the UK, and a lot of the overseas material was transferred to the Natural History Museum, or British Museum Natural History, as it was at the time. And that's why a project that we led, called the GB3D type fossils, we actually identified these fossils. We had about 25 institutions joined us to get all our type material re-photographed, stereo pairs of a lot, and even some 3D scans, and it's all online. So if you want to track down type fossils, you stand a chance at least of finding it on this website. And of course, visitors to the museum will be looking in some cases at type fossils. So you may just recognize, one or two may recognize the gentleman on the right here. That's a slightly younger Jan Zalasevich. But does anyone recognize this gentleman here? He was president of the Geologists Association, 1916 to 1918. He is actually George Barrow. And he was the geologist who mapped in Scotland and worked out the so-called Barrovian metamorphic zones. And in his paper here, you can see he actually refers to a particular specimen, number 4862. So you can go back to the original paper, find the specimen registration number, and hey presto, this is the exact specimen, or one of those that was used to define the Barrovian metamorphic zones. So you can go back, you can follow it right the way back to the original material that the person who defined the term used. Whoops. Okay, so uses. Now let's do a little bit of the history. We really start from, I guess, William Smith, who raised the profile of geological maps. In 1791, the Ordnance Survey was established. As I'm sure many of you know, this was the time there was a threat from invasion by the French. So they realized they needed to map the south coast so they knew exactly how to get British troops around should there be a French invasion. And that's why mapping, really good quality mapping, was started by the army along the south coast. And following Smith's work on maps, by the 1830s, Murchison, who was one of the key geologists in the first half of the 19th century, lobbied for William Smith to be officially appointed to colour up the Ordnance Survey maps to show the geology. But even in those days, he was considered just at 62 to be too old. And it was actually Henry de la Beach who persuaded the government to fund the survey, and it started really the earliest routes in 1835. There's more that can be said, but we could talk about that later if you're interested. By 1837, they had established, de la Beach had established the Museum of Economic Geology in Craig's Court in Whitehall. So this is here, it's just off Trafalgar Square. This is what it looks like today. The original 19th century buildings have all mostly been torn down. Certainly the ones where the museum was have gone, and replaced partly by a telephone exchange. And when one of my colleagues went down to get some photographs for an early version of this talk, he pulled his camera out, and you can see the policeman in the corner, and a colleague came up with machine guns, submachine guns, wanted to know exactly why he was taking photographs. And it turns out this is actually the back of the Ministry of Defence. But fortunately, he had his official pass with him, so he was able to prove who he was, and they said, fine, take the photographs. But it's worth, if you Google Craig's Court, you'll find that it's infamous because I think where the telephone exchange is now is the top of one of these entrances to the underground tunnels under London that was used in particular as control centres during the Second World War. So that's where the first museum was, but within a very few years, it was full. And so they started looking around for a new site. And this is where Derby Court came up. And they found what appeared to be a good site that ran from Jermyn Street through to Piccadilly. There was a series of tenements there, and they started to take them down. And that's when they hit the problem, because most of the tenements had got cesspits in the basement. And they found a building, and getting good foundations was very tricky. And it took from the 1845 or so, I think, right the way up to 1851 before they had the building finished. And it was opened by Prince Albert. This was the days when, you know, geological sciences were very much the in topic of high society. And it was really good that Prince Albert was a strong supporter throughout the efforts to raise money, and he then opened it. Edward Forbes, I've already shown you, was the first paleontologist, the first curator and publisher on fossils. And he was joined by John Salter, who was particularly keen on the older, particularly the lower Paleozoic fossils. And again, if there's time afterwards, I can tell you one or two stories about John Salter. This is what the museum looked like when it opened. And pretty much everything, all the crown jewels were there on display. Very different to so many modern museums where it's, you know, very little actually on display. It's mostly a few diagrams, blank spaces, seats, and the coffee shop. On the outside, another view on the inside. And behind the scenes, this is the headquarters of the survey. So they, most of the survey officers had offices there, and this is where they indexed a lot of the records. because as well as the headquarters of the survey and the museum, it was initially at least the Mining Records Office, and there was teaching. It was part of the Royal School of Mines. The first collector actually employed as a collector rather than a curator was Richard Gibbs. And this is some of the material that he collected. And in the really early days, they didn't really use the concept of the unique registration number hadn't really been recognized. So many of the earlier specimens were on tablets, and if they had a number, it tended to be the location in the cabinet where they were displayed to the public. And I've actually done quite a bit of work trying to work out when the numbering system we use started and where the idea probably came from. So here's some examples. G181. The survey uses a system of a prefix and then a simple ascending number. And certainly in some of the records, this is one from 1848, Gibbs's collection, G1. This is the first use that I can find in the survey of unique registration numbers. If you go back to 1847, this was a collection by Evelyn, and there's no sign of a unique registration number. So I'm pretty sure that the system really started in 1847. And it's interesting because we have a small collection of paleobotanical material that was curated by Hooker, and it includes some Darwin material. And we hit the press a few years ago now. A researcher basically said quite correctly that he had discovered Darwin material in the dusty hangars, as he said, at BGS. And we implied we didn't know we had it. Well, we knew we had unregistered material, but it's true. I personally didn't know, although I'm sure my predecessors knew that there was Darwin material there. But that collection was actually curated in 1847, just before the unique number system started. So that's why it was unregistered and why we had missed it. This is the official memo from Murchison a little bit later that instructs field geologists how to number their specimens. And this has never been rescinded. This technically is still in force. For 15th of November, 1858. And it basically says that the survey officers, including at this point Ireland as well, have to use the pre-printed number books. They will put their unique prefix and then stick the number on the fossil as soon as possible after it's collected. And this is what the books look like. And the interesting thing is they actually start with the lower numbers to the right rather than the left, which makes sense, of course, because you cut across from the right to the left. So you really want your 1 on the right rather than on the left. And to date, we have 1,754 unique collecting codes. Of course, today we don't do it by hand. We have computer printed numbers, but these are some of the codes that we've got. Most of them are routine, straightforward. 1 or 2 famous people in places. But if you go back historically, there were some characters. So right at the top, a gentleman called H.A. Allen refused to use letters. He used a triangle. And when he ran out of a straight triangle, he had a triangle with a dot in it, and then a triangle with a dot without a bottom on it. Now that was fine. You know, there was some nice characters in the survey in the 19th century. That worked well when you were doing it by hand, but when you try to put a triangle with a dot on a computer, it doesn't exactly work. So we had to introduce a series of codes to replace it. T. McKenny Hughes was another example of a character who worked at the survey, mapped quite a bit in the Lake District before he got the job as professor in Cambridge. And he used his initials, T. McKH. And when he got to the end of his book, he used his initials, but upside down. And again, that doesn't exactly fit on a computer system. So this is what some of the numbers look like. So this is a petrology sample, number 16 from Ascension Island. It's got the BGS number. Now it doesn't actually say MR, which stands for Museum Reference Collection, but it is, and it's got a cabinet label on it as well. This was one that was on display in the Museum of Practical Geology. This is one of the specimens that was presented to us by Charles Darwin. It's a Darwin specimen. And in fact, you can either download it from Google Books, or you go on the BGS website and you can find the descriptive catalogues of the rock specimens in the Museum of Practical Geology. This is the 1862 edition, and it actually tells you. So number 16, it tells you here, pearl stone containing small irregular masses of obsidian in this slightly tortuous layers. One edition of this actually has print on one side and blank pages on the other, so that the keen student can make their own notes as they go around the displays. Here's another example. Now the 797, that's an original Darwin number. So he stuck that on, I think, probably bobbing along in the Beagle at night. What intrigued me was 797, I know Darwin collected about 4,000 specimens, most of which are in Cambridge. This was from Ascension Island, which he collected towards the end of his trip, yet the number was only 797, and I would have expected it to be sort of 3,797 or something. And it was only when I checked further, it turns out that Darwin actually used colored to indicate the thousands. So white labels were 1 to 999. This is actually a faded yellow label, or a dirty faded yellow label. So it is actually 3,797. And what I did do, just out of interest, is take 3 Darwin labels and put them together to see whether he was using the system where we use of the numbers going in the books, go right to left or left to right. And actually here, you can tell by the way Darwin cut them up that his numbers were printed ascending left to right. But actually, I think it's quite likely that BGS did adopt the system that Darwin probably first used on the Beagle, only we did it better with our numbers printed the other way around. Anyway, the Museum of Practical Geology began to suffer in the early 1900s, possibly because of Zeppelin damage in the First World War, possibly because the Piccadilly line went underneath and may have disturbed the foundations, or it may be the legacy of John Snow recorded of the 32 cesspits at Derby Court. But basically the roof started to fall in. There were cast iron girders supporting the roof, and they found they had cracked. So they shut the museum to the public, they put scaffolding in, and they tried to work out whether they could repair it or not, and decided in the end, no, it would be easier to rebuild. So they eventually, when they'd rebuilt and moved, the original building was demolished, and the lease was bought by Dax, or Simpsons of Piccadilly, who were effectively the Dax men's clothing brand at the time. They bought a 99-year lease on the property for £11,000, and they opened in April 1936 what was then the largest menswear store in Britain. And Jeremy Lloyd, who some of you know, wrote a number of particularly BBC comedy programs, including Are You Being Served, actually worked in the Dax store as an apprentice in the early 1950s before he went off to greater things. And the store is now a Waterstones. It's their flagship bookshop. It's a grade 1 listed building because it had a lot of novel building techniques in it. So Waterstones is the site of where the Museum of Practical Geology used to be. So we moved from then, South Kensington, from Piccadilly, Jermyn Street, down to South Kensington. And I'm sure most of you will be familiar with this building. So they started construction in 1931 and began to move the collections in 1934, and it was officially opened by George VI in 1935. Some of you may vaguely remember what it used to look like before the survey moved the headquarters up to Keyworth, and then ceded the building to the Natural History Museum, who then got, I think, commercial investment, had a rotating globe in that rotated for the first week or two, and then I think failed. I don't think it's ever worked since. Right, a little bit of legislation. When the survey was established, it was put on a formal footing in 1845 with the Geological Survey Act. And passes actually say on the back that the bearer has the right, having given written notice, to go on anybody's land for the purpose of taking geological samples. So that gives the right to effectively go anywhere in the UK, or Britain at least now, to take geological samples. But a number of other legislations gave other rights. So the Mining Industry Act of 1926 required anybody drilling for minerals more than 30 meters deep, and a similar one for water more than 50 meters deep, had to notify the survey that they were going to drill. And when they finished, they had to keep logs of the drilling, keep samples, and the survey had the right to visit and to take samples. And here's an example. This is the Hardstoft. This is the first oil well in the UK from 1918. And survey officers visited the Pearson's yard in Chesterfield and took samples in 1918, December the 6th, and we still have those samples archived. And of course, we have the logs to go with them. In fact, I've been trying to put this together because it's never been fully written down, but the borings department, as they quaintly call it, seem to have really got going during the 1920s, which is of course when the museum was shut to visitors. So I think they used the hiatus as a good opportunity to pull out from the other collections and to get their borehole material properly organized. And the first run of borehole specimens, believe it or not, starts at B1, and the first borehole is Altcar in Lancashire, and it's some Kuiper marl and Shelly marl over gypsum. So they're some of the first specimens in the borehole collection when they were being held as individual specimens. And here's an example from 1945, 1946 of working on boreholes. And this is described, this is a Stubblefield photograph described as being in the yard at the back of the Geological Museum. And I've tried to identify, see if anybody around knew any of these characters. So I circulated this on the History of Geology list server, and I got some quite interesting replies, some very useful discussions. So the gentleman at the back with the thick glasses and I think it's a cigarette in a holder, looks a bit aloof, slightly receding hairline, was apparently Professor J. Prentice from King's. 2 people confirmed that, and I think that's quite likely. And the gentleman whose back's to the far was a BGS geologist called Gilbert Green. And he worked for the survey throughout, I think, his career. He looks a little bit shabbily dressed, shall we say there, and I am told that he had a reputation. People who knew him thought that he looked the way he did when he came to the survey because they thought he'd just come back from the field or was just about to going out in the field, and he was wearing field clothes. But somebody who accompanied them to the field found that he got even shabbier stuff to wear in the field. He also had a reputation once that he offered, I think he got a spare raincoat he offered to a tramp, and the tramp said, "I'm very sorry," and turned it down. So that's what working on boreholes was like in, we think, 1945, just after the war. Now, it caused a lot of discussion because people who work at the Natural History Museum said, no, that's not the back of the Geological Museum. It doesn't look anything like it. And they pointed to the windows now, which have got quite clearly good sills and tops. And yes, there seems to be blocked up possible windows, but there was uncertainty. And they raised the fact that around the door at the back there, the wall seemed to jut out. And I'm pretty sure the reason is, I've certainly had it confirmed, this was at the Geological Museum in the yard. What it actually is, that was a blast protection around the door, because this was actually used during the Second World War as headquarters of the London Civil Defence. And in fact, adjacent to it were a specially constructed underground bunker that was a very important headquarters for some of the civil defence. That was subsequently, they tried to demolish it after the war, but it was too well built to demolish. So the Natural History Museum then used it as a store for their marine reptiles. So there turned out to be a lot of interest when we tried to get some IDs on these characters. Anyway, in the 60s, the survey opened an office in Leeds, and they realized they needed storage, and they located near to Leeds in the Kippax station, which is on a line just to the west of Leeds. There was, at that point, a vacated warehouse that had been used during the war for supplies, and it was just the right size. So the survey took it over, and it so happened that the station master at Kippax had just been dismissed because of an accident shunting goods trains into a siding. So he was recruited as the first and only, I think, manager of the Kippax store, and he did a very good job. And it was there that the survey started keeping meter length, used boxes to be able to keep meter lengths of core. So that's kind of the history. Now moving to Keyworth, that happened, as I say, in 1985. Many of you have been there, many of you actually seen it. But I was well aware that when the survey moved, a lot of people criticized the survey for taking the material out of London. And by 2000, when I joined the survey, of course, the web was beginning to get to the point where it could be used to deliver images and data about collections. And that's effectively what we've done for the last 20 years. So we've done various projects. Not only have we got online searchable databases with the, well, I would call it metadata, but collections descriptions, the individual items. So you can search boreholes by name or location and so forth. Specimens by locality, by identification, rock type, collector and so forth. But we then went on to starting to image material, and we used for these are very high resolution images. The camera costs £25,000, but we were able to do, with a conveyor belt, we photographed 140,000 boxes in a year and a half when we moved the entire contents of the hydrocarbon archive up in Edinburgh down to Keyworth. And by using a conveyor belt, we were able to do it much more quickly. And I have to say that the concept of photographing all the core, I have to say a big thank you to Roy, because it was actually Roy Clements at one of our advisory committee meetings really hammered home the point that these were boxes of core at this point that visitors came and worked with. And we had absolutely no proof. We didn't stand over them all the time. They could have moved stuff around, and that he impressed just how important it was to have a photographic record, which is exactly what we have done. And slides, we've done a similar thing. All our thin sections have been imaged and are online. And rather than really high resolution, the aim is to have enough resolution for you to decide, is it worthwhile looking at the original thin section or not? So we've used an ordinary digital SLR camera and a fairly simple, straightforward workflow, mostly, I have to say, with volunteers. And of course, if you're not familiar, we have an online GIS, a geographical information system, series of maps. It's called GeoIndex. The link's on the abstract. And you can go on, you can pull up a map, you can pull up the geology, and you can see the exact points where we have all the rock specimens. And if you click on black triangles, that will then take you through to the image of the thin section. And this is what the thin section images look like. So I know they're good enough, and some researchers have told me they've actually published using just our photographs rather than actually borrowing and photographing at higher resolution. But for many purposes, certainly teaching and that, these are fine. Fossils, I've already mentioned GB3D. This is where we worked with about 20 odd institutions, including Oxford University Museum of Natural History, Sedgwick Museum, Cambridge, National Museum of Wales, and about 20 local museums to rephotograph all the types. And we also did stereoscopic pairs using the system that Mark Pennell from here actually documented in Paleontologica Electronica. And these are really good photographs. In fact, you can zoom in so much that you can even see the dust that we should have cleaned off probably before we photographed them. So if you had red cyan glasses, you would see that in full 3D. And if you're into 3D digital models, 2,000 of the better specimens have digital models, probably not as high resolution as you would want today, but they're there, and you can download the digital files. And the usage of the website has certainly increased very considerably. Unfortunately, the later figures are confusing because BGS has changed its servers, and I can't compare the current figures with these. One comparison suggests that we've gone from about 12,000 hits a month probably to about 50,000, but I can't say that's absolutely guaranteed. And finally, coming on to the future, well, we're trying to digitize even more. So the core, we can photograph it, but we're now using scanning facilities that use techniques like X-ray fluorescence to monitor the geochemistry, to do CT scanning, to measure a whole variety of properties. And we are starting to publish some of these again online, so people can download data about cores and decide which ones they perhaps need to examine, which could be useful for research projects. And to give you one example, one of the problems we had for a long time was trying to date using zircons some of the Chandra Forest rocks. And there's been a case where you could crush a large quantity of Bradgate formation, for example, and you got next to no zircons out of it. And it was quite interesting taking a small sample of the formation and scanning it. You see that the zirconium peak, the red line, it's actually one or two thin bands are very high in zirconium. The rest is very low. So this sort of technique certainly helps you select samples for other work. Whoops. So there's a series of other geochemical element plots. And finally, well, it is a system of national systems of pulling the databases together. So I've given links on our abstract to some of the BGS databases, but we're now in the early stages of feeding through to some of the international databases. We're already on a Chinese one called the Geobiodiversity Database, but and we're involved in there's an American one called the International Geosample Numbers. So that gives, again, fixed, unique international numbers that you can include in publications. And if you click on it, it will take it through to the database that's got the information about that sample. These are, for example, BGS specimens in the Chinese Geobiodiversity Database. But I think the future going forward is almost certainly in the Dissco project. And as I say, it's relatively early days. This is not officially announced yet. This is a sneak preview. There's actually very little data in it. This is actually based, this one is based on the GBIF, the Geobiodiversity, an international life sciences database. So this will almost certainly hold the UK life science collections. So anything that's living or stuffed or non-fossil, shall we say, and fossils. And at the moment, discussions are going on as to what form the database that will hold the rocks, the minerals, meteorites, cores, and so forth which clearly don't really fit straight into a life sciences database. So that, I think, is the future, and I think we will see progress here over the next couple of years. And that's really it. So I'm open for questions.
Thank you. So, questions?
Clearly, a lot of work was put into all this, Mike. What sort of manpower do you have contributing to this?
Well,
Can we just, I'll just repeat the question because from here. Yeah. So what kind of manpower do you have for doing all that lot?
it's an interesting question. A lot of the big digitization has been done as special projects rather than from standard central funds. So you could argue that most of the core photographs, because that was part of moving the core from Edinburgh down to Keyworth, that was actually funded by selling the core store up in Edinburgh, and that paid for building the new core store in Keyworth, all the photography, all the curation work, and the transport down. So you could say the core photographs were actually funded by Aldi, the supermarket, because they bought the site. As I said, the GB3D, the fossils, was funded by Dissco. That's the organization that runs the academic computer network. And they had a period in the 2011, 2012 when they funded a number of digitization projects. And we were lucky, we got in at the right time and got just under $750,000 to do that project. And the thin section photography, that's mostly done by volunteers. So the rest of the work and continuing that work is done by our team. And it's actually relatively small. We're probably talking about the equivalent of 2 or 3 people. And going forward under Dissco, it seems likely that they will fund 1 or 2 hubs. And we're hoping that we may get selected as the geoscience hub. And again, that's quite likely to fund probably just 2 or 3 people. So it's not a lot of people. You have to be very inventive in the ways that you actually get the work out.
Any other questions? Roy.
Just a general one, we did once visit the Kipak store in the 80s. What happened to it?
What happened? The question John's asking is what happened to the Kipak store for those on Zoom?
Right, the Kipak store, basically all the staffing leads, or virtually all the staffing leads, moved down to Keyworth. So, and the Kipak contents of the Kipak store were moved down to Keyworth. So that's when, in London, they used to use just these small wooden trays, which had the individual hand specimens. So the first 10,000 Warhols held as the roughly 1 million hand specimens, they were all in these initially wooden trays. That was effectively separate, and that was one part of the new build at Keyworth in 1985. And all the stuff in Kipaks, that went onto the big pallet racking that was put into the store, the other half of the main store they built in 1985. So basically everything in Leeds came down to Keyworth.
Roy?
Hi, interested to see how you're moving away from just rock and material to the data associated with it. How far are you going to take that? In the sense, are you going to start encouraging researchers to any data they generate from specimens in your charge to deposit copies of that data, or or analyses and things like that? Are you intending to go that way, and how far?
Yeah. So Roy's asking, moving in the direction of digitization, are you going to be asking people to deposit digital data with you as opposed to depositing rocks?
The answer is we're actually already there. So anybody borrowing material, certainly anybody coming into the core store, which is probably the largest museum type collection that's designed for subsampling. Anyone taking a subsample, they're required to not only return any preparations, essay thin sections or mineral separates or anything they produce from that, and any offcuts or residues, but they have to lodge the data as well. And on our website, we have a special portal that they can use to upload that data to. And I didn't show you, but when they take a subsample, say from core, they actually drop in a barcode. Because at the time they take it, we obviously don't know what the data is going to be. So they put a barcode in with a reference number, and then when they deposit the data, they have to include against the individual data for that subsample the barcode number. And that means in future, when the data is back in, that you can walk, in theory, walk around, just scan the barcode, and it will pull the data relevant to that point straight up for you. Doesn't always work, but that's the aim.
Okay, as the immediate questions here, I'm going to, if you don't mind, I'm going to stop the share and stop the recording.